today. Kurt's out and about. And yeah, I don't know. Rebecca might join us, might not. But yeah, we got Whitney and Jenny and Valeria here. So we're going to talk about recursion. It's super gross. I'll warn you guys at the start. How's the sound working for you, Valeria?
Good.
Awesome.
Good. Yeah.
Yeah, so recursion, we kind of touched on this on the stupid slides from Harvard College that weren't so super useful. But yeah, that's what we're going to be talking about today. So I want to start off with a little recap of functions. Again, we define them with def, and then we use them by using a name, calling the function. So we have this function prettyprint, which takes in an input that we're just using the variable s, and then we're printing out 4 spaces plus s, and that justifies our printed text by adding 4 spaces in front of it. So we can take in test, give this test 4 spaces, then test. Woo, that's exciting. Yeah, garbage, give us 4 spaces, then garbage. Yeah, so that's how functions work on a basic level. They can take data in, and then they process it and return the finished result. So we had this reverse string function last time that we took in the string s. It did this operation where it reversed the string and then it returned it back to us. And so we can take a string in where we have a string, we stuck it in a variable called test string. Then we did reversed string on junk, put it into this other variable, and so now we can use this variable we called reverse. We can print it out, or we can do other things with it. Basically, it's a way to hold on to that data once we're done processing it. Functions we can also call other functions. We had this pretty reverse, which took in the reverse function that reversed the string, and then it printed the result of that operation. And so pretty reverse did both the things at once. So I think I talked with Jenny a little bit about this after class, but one thing that's important to know is that functions only know what's inside of them. So I've got this new function, make Chathams. It takes in a string s and adds onto the front of it Chathams s, and then it pretty prints it, or pretty prints. I just made. It takes the original s. It says I just made s. Then it prints on the next line into this result string Chathams s. Then it returns that variable. So we're going to go ahead and that's object. Just make this variable called object. Put boat in it, the string in it. And we can have Chathams object is equal to make Chathams object. So just made boat into Chathams boat. So it turned it into this string, Chathams boat, which then got stored into this variable called Chathams object in this line from this return statement. And yeah, so we can tell if we look at, say, hey, what's in Chathams object? Hey, Chathams boat. But if we try to see what's in result string that we had up here, it gives you an error because it doesn't know what result string is. Result string belongs to make Chathams, and nobody outside of make Chathams gets to look at it. Similarly, you can't use a variable inside a function. You can't use it in another function. So we're same make Chathams function here. It has this intermediate step of getting result string. So we can pretty print that out and return it. So I had this other function, make mine too, that we were trying to do new result by taking me and then adding it to result string that we had up here. But when we try to run that, it gives us this error, this name error, global name result string is not defined because
you have to redefine it.
Yeah, you'd have to redefine it because this function can't see into this function.
Define it all over again. Yeah, definitely.
Yeah. Yeah. So
the depth, like close one function and start a new one.
yeah,
Wait, but you just said that functions can call other functions.
they can call other functions. So functions, when you do this def, it's like declaring the function to the whole world.
Yes.
But what's inside the function, that belongs only to the function. Like the function's like, oh, you can know who I am, and I'll give you back stuff with this return statement, but you don't get to look inside me. Yeah.
Sorry. Nope.
Is that making sense to everybody? Mm-hmm. Awesome. That anything that we define inside of a function, like we can't see into. We have to, and so that's one of the big reasons we have to have like the return statement, is that if we want to get data out of a function, we have to return it. There's no other way to get data back out.
So when you say function can recall another function, you mean like pretty print can call results string? Is that what that means?
Yeah, so we're calling pretty print inside this function.
Oh, okay.
So make Chatham's like we defined pretty print up here somewhere. So make Chatham can use that. It knows about it. Similarly, if we had another function, it could use make Chatham's.
So if we define result string separately, then we can call it. In that block. I guess I'm a little confused as what the difference is between why can't I use where we define it.
So pretty print is a function, not a variable. So functions.
Oh, and result string is a variable?
Yeah, and result string.
Oh, okay.
Yeah. So result string is this variable that we're using internally. And then we're calling other functions inside make Chatham's, but all the variables inside of a function, they're only accessible by the function.
Okay, but you can use pretty print because it's already.
Yeah, pretty print's defined somewhere further up here. Yeah. So
then. So then you can use repeat information that's in some functions, but it's already been defined. Functions, not variables.
Yeah.
That's better.
There we go. Excuse me. Oh shoot. You're just all looking at my face. I'm gonna run through these slides real quick when I'm actually screen sharing, so that everybody watching can actually see what the hell I'm talking about. Yeah. So function recap defined by def. When we use them, it's calling the variable or calling the definition. So we define them separately. Then when we actually use them, functions, they can take input and they return output. So the input is here in the parentheses when we're defining the function, and then the output is what comes from the return statement inside the function.
What's the double colon?
This double colon is like the start and the end part of the string. So it's just, it could like start at 0 and go to 5 if we only wanted to have like the first 5 characters or whatever. If we leave them blank, it automatically defaults to the start and then the end of the string, and then this is like how we move through that. Kind of a Python specific thing. Yeah, function can call other functions, which is about to get really important. Then yeah, we're talking about variable scope. So here are the actual slides that accompany things. We have we had this return this variable inside make Chatham's result string that when we tried to call it from outside of the function, we got an error. Similarly, we can't we're trying to use this result string variable from make chatums in a different function, and we don't get access to it. So if we're trying to call that, we get an error. Just to recap. Yeah, so functions can all call other functions. And yeah, so let's get at it. We can do this a lot. We can, basically have a whole like stack of functions. So we had this, reverse string function this time and last time. Then we also made this like double reverse function, which goes ahead and open up Python real quick. See it. Descriptor. Yeah, so we got our reverse string function. And this function double reverse, which takes in a string. It does reverse string to it. It stores that in this intermediary variable, and then runs reverse string on that intermediate variable and gives us a result and returns. So it basically is doing reverse string twice, right? So we'll go ahead and put that in here. And go reverse string chunk. This nudge. Or we can go double reverse, yeah. Junk. It reverses it and then reverses the reverse, so we get back to junk. We could, if we wanted to, we could define this triple reverse function. What it's going to do is it's going to go ahead and right in here. What it's going to do is it's going to say, okay, I want this intermediate value reverse twice. I'm going to reverse something twice, so I'm going to call double reverse on my string that I put in, and then I'm going to go ahead and reverse that. So we reversed it twice, and then reversed it twice, stuck it into this variable, and then reversed that again, and returned that. That makes sense? So basically, I have this function calls double reverse, and double reverse calls reverse string. So we go ahead and run triple reverse on junk. We'll get nudge again. Since it reversed it, then it reversed it again, reversed it again. So we can keep going if we want. We can do quadruple reverse, which on S, which goes ahead and calls triple reverse, stores that value, and then reverses that and gives that back. Or quintuple reverse, which it runs quadruple reverse to reverse it 4 times, and then it reverses that. So for the quintuple reverse. Or sextuple reverse. So we quintuple reverse it, and then reverse that. We get these, reverse it, gives it set, test, set, test, as we keep reversing it back and forth. This can definitely get out of hand. Fuck you, Mac. So what we're going to be talking mostly about today is that functions can call themselves. So whereas all of these functions were, we were creating all these individual functions that called like basically the previous function that we're calling different functions. A function can call itself. So we could create this like multiple reverse function, which we're going to give us some intermediate steps so we can actually see inside, see what it's doing. So it'll type us out reversing, whatever we get, does this reverse operation, which we got from our original reverse function. And yeah, so it'll print out reversing test into set. And then if I reverse that, it's going to take this reverse that we did, that we stored into rev, and it's going to call multiple reverse on itself. And so it's going to go ahead and, so we started with S, we reversed that and stored that into rev, and then it's basically going to take rev, run this function again, except whatever rev was, passes it into this. So I'll be reversing. So we had test, we passed it into S here. So we had said, reversing test. So we had reversing test into, then we did this operation, printed out into whatever the result of this operation was. So we got reversing set, test into set. Then if I reverse that, so we got, oh, I spelled that wrong. Reversing set, because that's what we passed back into itself. So reverse set into test. And then if I reverse that, and this will keep running forever. Because
It's a loop, just basically just keep coding, just tell it something.
yeah, almost. I mean, it's basically saying, okay, run this function, and inside this function, run this function that's actually this function. So it winds up creating this like basically infinite mirror
Yeah,
of,
so it's
yeah. So the one thing is what happens instead, it doesn't actually go forever. What you'll get is this runtime error, maximum recursion depth exceeded, which means that the computer said, okay, I'm going to run multiple reverse, and then I hit this line that says, okay, whatever rev was, run multiple reverse on it. Then multiple reverse rev is going to go down and be like, okay, I have to call multiple reverse. And then that function call is going to say, oh, I have to call multiple reverse. And it's going to keep building, trying to like call itself over and over until it basically, Python says, I'm out of memory. I can't store, I can't call this. So you're building up this like function stack. It's saying like that stack just got too big. Like I'm trying to call myself too many times, and I'm just out of memory. I'll go ahead and run this. Paste that in here. Reverse. And yep, that's big fat error. Let's see if we can scroll up. Let's see if there's anything. Oh, yep. So that went ahead and said, okay, reversing zebra into Arabs. If I reverse that, reversing Arabs into zebra.
So it just goes below.
And it goes back and forth and back and forth a certain number of times until goes quite a bit until it's like, whoa, what the heck? I am just, so notice it hit this. If I reverse that, which is this statement, it's the statement before when it calls itself. And then it's like, okay, I'm hitting this line, and then it figures out where the error was and it has to actually break it back through. And so then it's, oh, maximum recursion depth exceeded. Like this was just going on forever, and I'm like, I'm done with this. Is that making sense that how this function's calling itself? So it's taking the result that it has and running it on itself. So it's a lot like if you have like two mirrors facing each other, or yeah, if I go ahead and go to this, hey, it's the camera is, or the Google Play Plus window or the Hangouts window is showing the screen, which is showing the Hangouts window, which is showing the screen, showing the Hangout window, which is showing the screen, on and on forever. That's basically the concept of recursion. That we've got this guy Will Wheaton wearing a shirt which has a picture of Will Wheaton wearing a shirt with a picture of Will Wheaton on it, wearing a shirt with a picture of Will Wheaton on it. Yeah, and so something that obviously winds up happens faster in the real world than on computers usually, is that eventually you reach like a small, you'll need to reach like an end. You'll need to have a stopping spot. In this case, it's like, okay, there's only as big a, you can't print forever. You have to like be like, okay, this is the smallest part, and then we're gonna kind of build back out from there. So you have to have a stopping spot for your shirt of a guy wearing a shirt of a guy wearing a shirt. So yeah. So this process of a function calling itself is called recursion. It's because like the function is recurring, but we need to have a limit on it. So whereas we had this function multiple reverse, which just took in a string, one of the ways that we can limit it is say, okay, we're going to have this function, and it's going to take in a string s, but it's also going to take in the number of times that we want to reverse it. So what it's going to do is going to reverse it. It'll be like, this reversing test into set. It prints this out. Does the actual reverse operation and stores it into the variable, and then prints into in the variable so we can kind of see what's going on. And then if times is greater than 0, we go ahead and keep going. We'll say, okay, print, if we reverse that, let's do multiple reverse again on the reverse of what s was. But let's do it one less time. So we've got this variable up here, which which starts at 3. We go ahead and print out reversing. So s is test, reverse is 3. We go ahead and reverse test. So rev is set. Then if we were to reverse that, since times is still 3, so then we're basically calling multiple reverse on set. I'll be reverse of set 2. That's actually what's happening inside the computer, inside the program. So it's going to run multiple reverse on set twice. Then it comes down here, turns it into test. It's actually calling multiple reverse. So now S was set in this call. So it's set 2, so it prints out set, and it reverses set back into test, stores it in this variable rev. And then since times is still greater than 0, we go ahead and take that reversed set and then run it through this function, except with times -1. Is that making any sense for you guys at all?
Yeah. Basically telling it how many times to do it.
Yeah. So so you're saying call it with one less than you had before. So we'll keep going down for some more examples. And so this way, sure. Just going to copy paste this. I'm going to go ahead and throw this in. Oh, I have that. Oh, so I had. If you have white space in a function, to like give your next extra space, basically you'll have to put in like a full indent. So a tab or a space. Multiple first. Blah. 2. Blah, comma 1. 0. Let's start with 0. So that just does it once. So it takes it in, reverses it, prints it, and times is not greater than 0 because it is 0, and so it just reverses it. If we do 1, calls does all this, and times is greater than 1, so it basically calls itself. So yeah, it's basically doing this. So this is a very similar process to, when we had this big kind of list of double reverse, triple reverse, quadruple, quintuple, sextuple reverse that we're basically, so as we notice, we're basically doing the exact same thing in each step. We're finding out what the previous step did and then reversing that string and then returning that. So, sextuple reverse would figure out what quintuple reverse did and then reverse that. And then quintuple reverse figured out what quadruple reverse did and then reversed that.
So you would have to write out all those.
Yeah.
Have to back up.
Yeah. If we were just writing out just straight functions, we'd have to write all of the ones all the way back up. So, so we've got, let me go back to the video so I can show my hands. Video load up. So in that case, like when we had just sextuple, quintuple, quadruple, we had this big, like sextuple was this big thing that needed the result of quintuple, which needed the result of quadruple, which needed the result of triple, which needed the result of double, which needed the result of result. So then we kind of figured out that smallest result, and then we can use that to answer what's double repeat S. And we can use that result to figure out what's triple result S. And then we can use that result to figure out what's quadruple reverse S. And then we can use that to figure out what's quintuple reverse S. And use that to figure out what's sextuple reverse S. So this function, needs a result of another function which is doing less work, which needs a function but that might still need the answer of another function which is doing even less work. And we'll get into a little bit more of like two different ways of thinking about recursion and how it works. But so this kind of multiple reverse function. So instead of naming them all out, we're kind of creating this like generic reverse function that can be run an arbitrary number of times. So like if we wanted to only run, actually reverse that to 1 to make this code work better. So if we only wanted to reverse one time, put in multiple reverse S times, and it would reverse S and print it out. And then since times was not greater than 1, it wouldn't call itself again. It would only do this code. If times is equal to 1. It's a goal reverse. One. Result reverses golf into flop. Went through. It's like, okay, I'm gonna reverse golf 1 times. Times is equal. So it says, printing it, and it does the reverse operation. And up times is times greater than 1? Oh, it's not. So then I just stop. But if you do multiple reverse of 2, so it's doing multiple reverse of 2, it's saying, okay. So that's a lot like our double reverse function, right? So we have our starting, golf. We reverse that. And then, times is greater than 1 because it's 2. And so let's do multiple reverse of whatever we got in this first reverse that we did. And let's reverse that to -1 times. So let's reverse that 1 time. And so this winds up reversing it once. So this is like, so it all kind of stacks up on each other. And so we'll kind of, so this multiple reverse function is this general case of what was the specific function of double reverse, triple reverse, quadruple reverse, whatever. And so we could actually implement, now that we have this multiple reverse function, we could implement double reverse by just calling multiple reverse and giving it, oh, we're going to reverse this thing 2 times. And that's going to be double reverse now. It's basically the same operation that's going on. So, like, they're really, this is kind of going to be the bulk of today's lecture. I'm going to get a drink actually real quick. Look at this slide real quick. So there's two ways to think about recursion. Either we can think about it as building up from something small into something big. Where so we have this problem where we have a big chunk of data that we want to process. And so we can solve, step 1 would be solve a little bit of the problem. Step 2, solve a second little piece of the problem and add it to step 1. Step 3 would be solve another little piece and then add it to step 2. Step 4 would be solve a little piece and add it to step 3, and so on and so forth until you finally get to step n, where you solve the last piece and then add that to like the previous piece. Is that making sense?
What's N1?
N minus 1.
What's N?
So n is just an arbitrary number. So step 3, 4, 5, n could be 60, n could be 83, n could be 5.
N's the last piece.
Yeah. So if if our problem is size n, yeah. So like if we're going through a list that has n elements in it, step 1 would be to solve the first element. Step 2 would be calculate on the second element. Step 3 would be work on a third element up until the nth element. So it's just, basically counting up until, so that's kind of taking something small, and every step, every time you're going through the recursion, you have this like little answer, and then you're adding the next step onto it and into this like answer. So step 3, when it's solving, so step 1 solves a little piece. Step 2 solves another little piece and adds it to step 1. Step 3 solves another little piece and adds it to step 2. But step 2, the answer we got from that is like the first and the second together, because we, when we did this add it together. So n is solving, piece n, or the last piece, and it's adding it to the combined addition of every step before it. So that's one way to think about recursion. That's the one we'll talk about first. The other way is thinking about it and taking a big problem and separating it into small pieces. And solving each of those until you've solved the whole problem. So in that case, you do step 1 would be separate the big problem into one small part and the rest of the problem, the big part. Step 2 would be solve the small problem and then add it to step 3, which is do step 1 and 2 with the leftover big part from step 1.
That part doesn't make any sense to me, but that other side makes sense to me. Like the way my brain works, that does not make any logical sense to me.
Sure.
I think that's very interesting. Like that, I'm just like the first is separate the big problem, small part, big part.
Yep.
Then solve the small problem. Then add to step 3, which is backwards. You solve the small problem. Then do step 1 and 2 with the leftover big part. Step 1. Oh, okay, so you're just doing it the reverse kind of.
Yeah.
And then stop when the small part is the whole step 1. Yeah, but that is.
Yeah.
That's
got some examples.
And that's additive on the left.
Mm-hmm.
So the only way I can correlate with this is have you ever made sculpture before? It's just do you carve into stuff, or do you have to build stuff? I'm a builder. Start with furniture. Then I'm gonna put some stuff on there. Then I'm gonna wrap it up. Then I'm gonna paint on it. That. I get it.
Yeah, I'm gonna actually keep this language. And this I think with the example, there's an example we'll get into that makes this breaking into something big into small pieces clearer. Like it's easier to kind of see just the way that the data is written out. But we're going to start out with building something small. So I'm going to grab a drink real quick too. Oh.
Goodness, let's start from something small. I really got that one. Oh my god. It's funny though, I see like all this correlates directly to like teaching anything. Even like when I'm teaching drawing right now, it's like, well, you can't really draw anything until you know you have to define what tools are, what paper is, what marks are, how to use your mark, what's value. You have to like pinpoint all the stuff before you can actually draw.
So welcome back. We're going to start building things from something small. That's one way to think about it. So we're going to kind of go through these steps. So we're going to have an example problem that we're kind of going to work through. I'll just be copy pasting into the terminal, and all the code will be is on the slides.
Okay.
So our example problem is we're going to have a string, and we want to count the number of A's, the number of letter A's in that string. And then we're going to do this kind of very similarly to how we did the multiple repeats. So step one is solve a little piece of the problem that you know how to solve. And so we know how to, so we're going to create this function A's from 0 to 0. So starting at 0 and ending at 0 of this, like the 0th index of the string. So we know how it's really easy for us to figure out if the first letter of this string, which is at index 0, is A. We just see if my string 0 is A, well then the number of A's is 1. Otherwise, the number of A's is 0, and we'll return that. Is that making sense? So you've got this function that counts how many A's are in a string from position 0 to position 0. So, and we're going to go ahead and test that as we develop our code.
0 to 0, that's just the first, that's just one letter.
Absolutely. We are finding a little piece of the problem.
Oh. It's been a long day.
Mm-hmm.
Where you're like, hang on.
Yeah.
Yep. Yeah. So a lot of recursion is like figuring out what is like your base case, what it's like, and a lot of times it's like real basic. It's like, hey, well, I'm going to try to count the number of A's in a string. Like, well, what's the first letter? Is it an A or is it not an A? And that's, 1 over the length of the string. That's 1/nth of the way to solving your problem. We're further than we were when we started. So step 2, solve another little piece of the problem and add step 1. So whereas we had this problem, this function A's from 0 to 0, let's write a function that's A's from 0 to 1. So this is where we start thinking recursively. Instead of basically like, oh, find the A's at 0 and find the A's at 1. Well, we already know the A's at 0. That's A's from 0 to 0 for my string, right? We have a function that does that for us. We don't need to do it again. So we're going to call this function and store the value for that, number of A's. That was step 1. It's making sense?
So, yep. So now you're calling it it was my string, so my string is going to be, that's its nickname.
Yep. So this is the input that we had. We're gonna call that. We're gonna call from my A's from 0 to 1 with whatever my string is. We're gonna pass that to A's from 0 to 0. And the result of that, so this was step 1. This way we figured out in step 1. We're gonna store that value, and then find out, okay, what's in 1, or what's in the second letter of my string. Is it an A or is it not an A? If it's an A, we're gonna add 1 to the number that we got from step 1. Does that make sense?
I see this is going to totally.
Yeah.
That's awesome.
And then, so, okay, now we have strings, the A's from 0 to 1. And then we return that. Awesome. So step 3, solve another little piece. So, did I just not write the code here? That's embarrassing. Let me copy paste some stuff real quick. I screwed up my slide.
Okay, I want to go back to this. So we already need to go back. So we find A's from 0 to 0.
I'm just out of.
My string.
There you go.
So
it is
0 to 1.
0 to 0. So
Plus my string.
yeah. So we had A 0 to 0. We figured out what was in the first box. That's its own function. So we can call that function from A 0 to 1 to get the A's from 0 to 0. Figure out what's if 1 has an A, then we figure that out. So we can write this function A's from 0 to 2, which, well, we need to know what are the A, how many A's are there from 0 to 1. And then figure out, is there an A in position 2? And then add, so figure out the A's from 0 to 1, store that in this variable number of A's. And then we figure out if position 2 has an A, and if it does, add 1 to the number of A's. And if it doesn't, add 0 to the number of A's and return that. Making sense?
Mm-hmm.
Vaguely, I feel like I couldn't write it. Each one would write it.
Sure. This is more about like figuring out the concept is like, I hope, at least reading this will kind of make sense. And so notice 3, like basically at this point for step 4, we're going to find the A's from 0 to 3. You notice the difference between these slides, like the numbers are just changing.
So the function A's from 0 to 3, okay. You're changing the function as you go.
I'm writing new functions.
Writing new functions for each one.
For each one.
So right now we have four functions.
Yeah, so right now we're not doing pure recursion. Right now it's like when we had the double repeat, triple repeat, quadruple repeat. We're making a bunch of functions. We're doing that so we can see the pattern.
Yes.
Um,
Yes, so you're basically just changing 0 to 3, 0 to 3. That's what
Yeah.
you're doing.
So 0 to 3, we're going to figure out by figuring out how many A's are there from 0 to 2, and then figuring out, what's in position 3, and adding that. So we got some test cases over here. So this is the down to step n. Solve another little piece of the problem that and add it to step n minus 1. So we're going to create this function, A's from 0 to n. And so the big thing we need to do to jump from these like special cases, these specific cases, okay, we need to figure out from 0 to 3 to the general case from 0 to n, is we have to figure out, okay, if the string, since we don't want to repeat forever, we have to have this base case. So if n is less than 0, we're just going to return 0. Like importantly, we are not going to call the function. We're not going to call another function. We're just be like, okay, if n is less than 0, if we're going to go from like A's from 0 to, if that were -1, that doesn't make any sense. So A's from 0 to 0, we can do anything less than 0. Like there aren't any A's in a string that has 0 or fewer letters in it. So we have to say that. Then, like I said, we figure out what are the number of A's. A's for every step before n. We have this A's from 0 to n of our string, and n minus 1. So that winds up turning this function is effectively A's from 0 to n minus 1. And then kind of like in all of our other things, we're just figuring out is the letter at whatever position n, is that an A or not? if we have an a at position n, we add 1 to the number of a's, and otherwise we don't. We add 0 to it, and we return that.
So n is just the end of the string. What is
N is just a number that we're using, right? We have yet to like.
define what that is? It's not an actual thing.
We're not fixing it. We're just saying. So this function, we'll talk in
Oh,
the next slide. We'll
okay.
talk about this. But this is just extending this pattern. You know, we're writing all these functions: a's from 0 to 1, a's from 0 to 2, a's from 0 to 3. And we're making a general case: a's from 0 to n. And in order to make it work, we need to have this. We need to know what. We need to be able to tell the function what n is. So we could write, you know, a's from, it's like we had this test case, a's from 0 to 0 of 4 a's. And well, from 0 to 0, there's 1 a. So we have this function a's from 0 to n. And we're saying n is equal to 0 when we're calling it here. And hey, we're counting from 0 to 0. And we're getting 1a. We're counting from 0 to 1, which is so it's giving us the same result as a's from 0 to 1. Similarly, we're saying in our function a's from 0 to n, if n was equal to 2, we get 0, 1, 2. Hey, that's 3 n's. A's from 0 to n, if n was 3, we get 0, 1, 2, 3. All right, there's 4 n's.
So n is just
Yeah, so so we have this function, and so this is, and remember, this a's from 0 to n, that's just a label. We could call this Jeffrey if we wanted to, but we want to have like descriptive names, and so a's from 0 to n, it takes in a string that it wants to count, and then it takes in a number, which is going to be n.
it needs
Yeah.
Oh, okay. That makes a lot of sense.
So we wrote this function that said, let's define this function then from a's from 0 to n, that takes in a string and takes in a number, 0, 1, 2, 3, whatever you want.
Somewhat cool.
Great.
I did not know that n meant number. I just thought it was just something.
It's a variable.
I decided to put in there.
It could have been X. It could have been
Can't
Susan
could
B.
it-
Anthony.
Could it be any of those things? Because
You can name it whatever you want it to.
oh, okay.
It's just a variable. And makes sense in this case.
It's definitely
Yeah, I mean, recursion is like a really like complicated thing. Like it's really hard to like get your head around. Like, I mean, it's definitely it's something that's hard to like think of something that like refers back to itself. I mean, it's very like snake eating its own tail, and figuring out a system that does that and still works. Yeah.
closed circuit.
Yeah. So it's this like closed circuit loop.
Yeah, that was rough.
Yeah. So kind of getting to Jenny's point. So we had this function a's from 0 to n, and so we had to tell, okay, how far along this string do we want to count? It doesn't. So because Python's an interpreted language, if you put in, baseball, a's from 0 to n, a baseball, it would be like, okay, I can do that. And then it would kind of like, wait, I can't compare baseball to 0. That doesn't make sense to me. I'll give you an error when you try to use the function with nonsense. I mean, let me go ahead and put this in. Let's see exactly where the error. I'm not totally sure exactly where the error will be, but the error is 0 to n. a comma potato. Yep. Unsupported operand types for minus. Mine's 6.
So it knows the n.
It knows that it needs.
Variable get set up. How does it know that n is 0 to n? Okay, comma 0, that n.
So it's matching a pattern. So A's from 0 to n. Okay, we've got def. Def A's from 0 to n. So we're defining a function. Python knows that. Then it knows that it takes that function, because it's from this parentheses block, Python knows that this function takes in 2 variables, myString and n. And so it's just matching this pattern. So it's taking whatever's in this first slot, filling it into this first slot. Whatever's in this second slot, filling it into this second slot. That's how function calls figure out what their input is. So like actually I was wrong. Apparently you can compare baseball or potato to 0. It screwed up when we came down to this line. I was like, okay, let's take whatever n is and subtract 1 from it. And it's like, I can't subtract 1 from potato. So yeah, so unsupported operand types for minus, string, and integer. Yeah, it's like, I don't know how to do that. So yeah, so kind of the like final thing that we might want to do is if we want to count all the A's in a string, we could write another function that would like wrap around this whole thing. So we might have count A's that only takes in a string, and figures out, okay, what's the length of the string, and then does A's from 0 to n on the string and whatever the length of the string is. We had to subtract 1 from it because, as you remember, strings always, like since the index starts with 0, if we have a 4-character string and have characters at position 0, 1, 2, and 3, and 4 is, if we tried to be like, okay, myString bracket 4 bracket, like that doesn't exist. Say again? Yeah. So we're not doing, we're not slicing, we're not using that. So we're just taking the length of team here, which would be 4, and subtracting 1 from that. So yeah. So if we had team count A's in team, we can go ahead and we've got this variable we're setting up slane or slen, just so everything would fit in. I'd probably usually be like string length, but I just want to fit all this into half a screen. So we got slen, which is the length of myString, so the length of team, which was 4, minus 1. Because we want to go A's from 0 to n, so we want A's from 0 to 3. So yeah, so I'll go ahead and copy paste that. If we don't have the minus 1, we wind up with a index out of bounds error. So A's, 4 A's again, so we get 4. Team. We get 1 A in team. But if we were to just do the length of the string, cut that out. This string index out of range error, because we're trying to do, what that's trying to do is it's saying that it's trying to be like A's from 0 to n of team. Well, 4, since you have 0, 1, 2. It's not a 4. Exactly. So, yeah. So we have to have the. This is pretty common when you have the length of a string or the length of a list or something. If you need to use an index from that, you'll want to subtract 1 from it. Or usually you'll wind up subtracting 1 from it just in various uses. So this basically like this just like idiom. It's like length minus 1. You'll see that a lot. Just because there's no index at length. You run out of your string or you run out of your list one before that. I'm going to kind of pass this. I'm not going to really talk about this. You can look at the notes. It actually write count A's completely recursively. So basically rewrite A's from 0 to n in such a way that, like, since n changes systematically, have n string slicing things. I'm not going to talk about that. It's kind of a hybrid between the breaking it down versus building it up, or building it up versus breaking down. And this stuff's confusing enough already. So that slide exists, though. If I've got comments in the code, this code should run. Feel free to poke around with it and rip it apart if you want to mess around with it. But yeah. So the other way to think about recursion is breaking down something big into smaller pieces and then operating on those smaller pieces, or breaking down something big into smaller pieces, taking those smaller pieces, breaking those down further, maybe taking those even smaller pieces, breaking those down even further until we get to something really simple that we can solve. It's gonna be like, it's that
hopelessness.
Exactly. It's a journey of 1,000 miles begins with a single step sort of thing. Like, eating a 64-ounce steak is like, well, let's take it in half. And you cut that steak in half, each of those sides in half. All of those pieces in half. And eventually you have bite-sized pieces. You'll have to eat a lot of them. So, yeah, kind of this weird recursive repeating thing. Step 1. This one's going to be counting, so you can actually go up to the going at the same time. Step 1 is going to be separate the big problem into one small part and one big part. Step 2 is going to be solve the small part, and then add it to step 3. Because what step 3 is, do step 1 and 2 with the leftover big part from step 1. So we had a small part, we did that, and then we still have the rest of this problem, so we're going to do the same process to that. And then eventually we're going to run out of problem to do. So this is to continue the steak analogy. That's okay. We're going to cut off 1 bite of our 64-ounce steak. We're going to go ahead and eat that. And then we're going to go to step 3, which is, repeat step 1 and 2. So cut off small pieces and eat it. And so we're going to beat that again with our slightly smaller but still big piece. Eventually, we are going to hit a point where we, eat our last bite. We have 1 small part, and well, we're out of big part to eat, so we stop and get steak for free. So we're going to have this count Z's program. So we're going to separate the big problem into 1 smaller part and 1 big part. So small part is going to be the first letter of our string. The big part is going to be the rest of the string. Tracking? Step 2, solve the small problem, and then add it to step 3. So this code in the next couple slides is not going to run on its own. We'll have to finish it before it actually works, because we're going to do things like, okay, here's step 1, small part, big part. Step 2, we're going to solve the small part. If small part, which is the first letter in the string, is equal to 0, then step 2 result is going to be 1. And if it's not, step 2 result is going to be 0. And so our final result is going to be, final result. That's great. Final result is going to be step 2 result plus step 3 result. We don't have step 3 result yet. So that's why I'm kind of leaving that for now. So does step 2 make sense? We're breaking small part and big part, and we're just solving small part. And then add it to step 3 is we're taking our small part, the result of our small part, and then adding it to the result of step 3. It's going to be the result of our big part and to our final result. So then step 3 is do steps 1 and 2 with the leftover big part. So here's step 1. We broke it into small part and big part. Step 2 was we solved for small part, and we got step 2 result. Step 3 result, and what's important to kind of notice that this order is a little bit like these things are mixed in together, whereas we had final result down here right after step 2. We have to do step 3 kind of in between. Otherwise we won't know what step 3 result is. So yeah, we have step 1, break it up. Step 2, solve the small part. Step 3, we're going to do step 1 and 2 on the big part. Does this line of code make sense? Awesome. Yeah. Sure.
The small part, solving the first small part.
Yeah. Awesome. So we've got our string. Let's say we have zebra. So yeah, so we have zebra. So small part is going to be the first letter. It's going to be a Z. And then big part is going to be, let's spend some comments. My string is zebra. Small part equal to Z, right? Big part equal to zebra. So we're tracking on this, right? So now we go down, okay, small part is equal to Z, and step 2 result is equal to 1, and if not, step 2 result is equal to 0. So I'm going to go put in a comment here. Results equal.
Is this Google Docs? So is this like, is all this going to be in your slide?
Yeah. Yep. So at this point, step 2 result is 1. That making sense? Yeah. Now we have to do step 3 result. We have to figure out what that is. So what we're going to do is we're going to call this function again on the part that was left over. On Ibra. Yeah. So now I might copy. I think we're actually pretty much done here, except for step 4. Copy paste this slide a bunch, and we are actually going to run through this. We had zebra, and Z and Ibra. Step 1 result was that. So now we have Ibra. It's going to be E, and it's going to be Bra, right? So this is where we're running count Z on big part, which when that was Ibra, we go back and we count. So we got Ibra, E, and Bra. And then so step 2 result for this step is going to be 0, right? So step 3, so then we'll have to figure out step 3 result. Final result is going to be step 2 result plus step 3 result, and we're going to return that. And that value is going to go back up into here because we're in this part of the code, right? Zero. We got bra and RA. All this, right? Oh, I'm doing that wrong. Sorry. That should still be myself. Sorry about that, because we're still wanting to just compare whether or not small part is, and it's not going to be for the rest of this. So it's going to be 0 again. I have RA. It hasn't yet, because every step we go into, so we start with zebra, we get ibra, then we get down to this line and say count Z. So we start running this again on the big part. So every time we're hitting this, we're saying, okay, I have to wait until I get the result. So I come down, and so this time I got an ibra, and it's okay. E is not a Z, so I get down to this line and say, oh, I need to do steps 1 and 2 on the big part again. So I need to call count Z on big part. I got bra, then I got bra, and so the big part, so the small part here is R, and the big part was A. So calculated, like, is small part equal to Z? No, because it's R. So that's still 0. Yeah. And finally, I get to a point where I'm like, okay, my string is just equal to A. And small part is going to be A. The big part isn't even going to. So then, yeah, A is not a Z. So I get 0 again. Then, okay, I go ahead and say count Z a big part. And that's what we need step 4 with. Stop when the small part is the whole problem. So we have to do this, okay, if the big part length is 0, we're going to go ahead and return step 2 result. So, okay, well, big part was 0, so step 2 result was 0. So, oh, sorry, let me go back to this. So, yeah, so this returns 0. Yeah, and that's, so we got the 0. So final result was step 3 result, which was 0, plus step 2 result, which was 0 at this point. There's the final result, which then gets returned back up to the last one. So this was waiting for count Z from big part when big part was A. So we know that. We put it into step 3 result. So that result plus step 2 result from this point goes into the final result, which gets then returned back into this next one, which then gets added to whatever we had in this step, then gets returned back into this one, which is all the way back up until back to our first call when we were calling this against zebra. Count Z. So we finally know what the answer to count Z of ibra is. So trying to summarize again. So count Z for zebra. Went ahead and figured out if Z was equal to Z and gave us a 1. And ran count Z on ibra, which figured out if E was a Z or not. And then, but also that did count Z on bra. And that function call did a count Z on ra, which did a function call of count Z on A. Well, there was nothing left. So step 3 result at this point, yeah, because count Z on ibra is 0. So step 3 result gets that. So the final result is step 2 result, which is 1 here, and adds it to that. And so the final result is 1. So it's 1 Z and zebra. 1. This, yeah, it's kind of that whole.
Like, Here's my big problem.
Yeah, it'd be kind of like, yeah, so it'd be kind of like, okay, you know, you have a mental process that is, you know, figure out how much I spend on everything. So you'd be like, okay, how much do I spend on childcare, and then how much do I spend on everything else? And so we have the childcare part. So then we figure out, okay, you do the same process, ignoring childcare on, you know, how much am I paying for everything else? How much am I spending on just that part of my life? Everything else minus childcare, food, plus everything else. You kind of break down. Yes, breaking down all of your expenses as childcare plus everything that's not childcare. And everything that's not childcare is food plus everything that's not food or childcare. And everything that's not food or childcare is your rent plus everything that's not rent, food, or childcare. So that's, you know, so that's this recursive process. You know, we have this, so we're doing the same process over and over for each time. And this could be our, you know, eat steak function, or walk one step function, or or take a journey function. I guess would be this. This would be, you know, your take a journey function, and it would be, okay, break it down to one step, and, you know, all the other spaces. Then we go ahead and do that one step, and then add it to, you know, how we do the same, you know, take a journey on the rest of the journey. And then we finally add it to that step that we took, and that gets a sort of result. So it's basically what we're doing. And this is basically saying, okay, if we're finally at our destination, we need to make sure that we actually stop walking. I'm actually going to rewrite this to be a little bit nice. Actually, we're going to keep going because we need this part. So our example stuff into this. Okay. Small part. Let's go to A. All right. Let's go to my empty string. So yeah, so this kind of stop thing is okay. So we have our small part and we have our big part. So we do the calculation, step 2, figure out, you know, if the small part is equal to z or not. Then we want to check, is big part, like, does big part exist? Do we have, you know, because yeah, we're testing, is small part the entire problem now? Because, you know, we've eaten 63 bites of our 64-bite steak. And so this last small part is the last piece. And it's the last, is, you know, the last step of the journey, small part, because there's no big part left over. So if the length of our big part, the length of our journey is 0, well then, hey, the small part, the answer is small part, that's all we need. We don't all count z again, because we just stop at the return statement. Yeah, and that's basically it. It's, as you kind of move forward, I'm probably going to write some new homework as opposed to I'll send you guys an email about that tomorrow, hopefully. But yeah, I wanted to kind of sidebar again, which we did like we did last time. How do I know my function is working? Because especially with recursion. It can get kind of confusing. And print statements are your friend. So I've kind of rewritten our kind of full. Oh, heck. No. That's not you. I hit Control Z instead of Control A. So I added in a couple of print statements that are going to show. So count Z's. Zeppelins with a Z. So
yes.
this is showing what's actually going to go on. So small part was Z, big part was Zeppelins. And then it ran, running again. Small part was E, big part was twins. Small part was P, big part was, yeah. What? Oh, that's because it's a capital Z. So, about this function is it does not know about capitals. Yeah. Yeah. So, yeah, we did small part with Z. We figured out, is that a Z or not? Then we figured out, is that a Z or not? We figured out that Z or not. That is Z or not. That is Z or not. That is. So at this point, we were like, okay, I've got a Z, and I just need to, so that, it's going to be a 1. And I need to add that to the result of count Z on Zeppelins. I'm really bad at spelling. But, and then so count Z of Zeppelins got me, small part was E, is that, I need to count that, plus whatever count Z of Pliz is. And running that gave me, okay, I need to figure out count that plus whatever count Z of Pliz is, all the way down until we kind of finally got to the end. So okay, I've got a Z here and nothing else in big part. So okay, I've got 1 here in the small part. And then we add that, so that answers what's count Z of Z. So I add that to if I is 0 not, so 0. So that gives me the answer to what's count Z of is, which I add to 0, which gives me the answer to what's count Z of Liz, which I add 0 to, that gives me the answer to what's count Z of Pliz, so on and so forth. So we finally get to, okay, now I know the answer of Epliz, and I add the 1 to it for this Z I see up here. And that finally gives us the answer to. So we kind of like go down, and we go back up, get our answer. The same thing, so found the first Z, then we needed to add it to where our big part was. Okay. I'll change this. So be a little bit more sensible. So, yeah, so the first time we ran through this, we had small part was a Z, and we still needed to know what the count Z of Zaz was, and so on and so forth. Small part was Z again, and I needed to know the count Z of As was, and so on and so forth until we got finally to small part was A, and we need to know counts of, and we know that that is 0. So, hey, there's 1, there's 2, there's 3, and there's 4. That gets us. Yeah, so I've finished up. There's some other things about recursion, like it's complicated. It's not usually how we tend to work, like sequentially, linearly. Like, okay, you do this, then you do this, then you do this, as opposed to you do this, then you do this again, but just on a smaller part, or then you do that again on another smaller part. It's hard to keep it all like in your head at once. Okay, yeah, and with that kind of breakdown between, okay, you can kind of think of it as, okay, we do a small part, and then we do another small part, and then we do another small part, and we're adding those together as we go. And we're building up from small parts. Sometimes that's useful, and sometimes that'll make more sense. Sometimes it'll make more sense to be like, okay, we have this big problem, and I want to break it down to, got this 64-ounce steak, and I want to eat one bite plus the rest of the steak. And I want to eat the rest, like one bite of that rest of the steak plus the rest of that, so on and so forth. And then also this is probably like when you actually will use recursion in the real world. You don't have to just divide it into like one piece and the rest. It's really common to divide it into half. Like, okay, I've got like this steak, a 64-ounce steak, and I'm going to divide it into two, and I'm going to eat half the steak and then the other half of the steak. And with each half of the steak, it's like, okay, I'm going to divide that by two. And so I'm going to eat each half of a half, and then eat the other half of a half and the other half of a half. So kind of breaking it down, cutting it in half. I think actually one of the homeworks later on in the Harvey Mudd course is like you'll draw like a tree. You'll have a certain number of steps, and each tree will be basically one branch that draws a line, and then it draws two other branches sticking out from that line. So one branch creates two branches, which create four branches, which create 8 branches. Each branch it's like shorter. I think it makes like distinct trees. But yeah, so that's class for today. I'm going to try and get some homework out to you guys. That's really going to more focus on just getting more experience in practicing just writing functions. That's going to be the bread and butter for your programming life. Recursion is a really important topic to learn about. It comes in useful here and there. And it's definitely, artistically, there's a lot of interesting things you can do with it. And like the concept of something kind of referring to itself is definitely something that you will wind up using a lot. Kind of the reason it's put at the start of this course as opposed to kind of the other way of doing things repeatedly is called iteration, which you will use way more often. But starting with recursion is useful because like if you don't have access to iteration and you have to use recursion, like you'll actually use it once or twice and actually learn how and actually get some experience working with it. Which if you learn iteration, you'd probably just be like, why would I ever do anything with recursion at all, ever? So this is kind of the tough love approach to computer science class teaching. But yeah, it's useful. It's good. I'll be around for questions, whatever. Shoot me an email, hit me up on Skype or Hangouts, or give me a phone call. Yeah, recursion is something that is really hard for most people to really wrap their head around. That's the reason I wanted to devote basically an hour and a half or 2 hours just to it. I think this is probably the conceptually most difficult thing we'll do in this course. So it's downhill from here.
Probably.
But it's definitely something that, I think it definitely relates to some other things and gets you starting thinking about how these things all work. So yeah, thanks for showing up and having patience with me, and
Thank you.
yourselves.
Good night.